In this video, we'll talk about vectors in the plane. So vector looks like the graph that I have here. Its notation, it's PQ with an arrow on top. It starts at P and it ends at Q. P it's called the tail, Q it's called the head, and a vector needs to have a direction. Like in this case, the direction is this one, it goes this way, and it has to have a magnitude, which means a length. So it is this long as the blue line goes. So I need to have a direction and I have to have a length for to have a vector. Now, two vectors that have the same length and they point in the same direction. So if I draw this, considering that these two lines, the blue line and the red line, are parallel, and let's call it AB. AB would be an equal vector with PQ because they have the same direction and the same length. Now, the vector RS, for example, is not equal to PQ. It has a different direction, it has a different length. So if I want to, for example, we have the PQ that we have here, this one in green. And if I want to find 2PQ, well, I would have the PQ and then double that, and this would be 2PQ. If I want to find 1/2 PQ, for example, then I would have my vector that we had before, but we would draw just half of it. So parallel, but make sure you have half of the length. If I want negative PQ, then I would draw the same direction, sorry, the same length with the green one, this one, the same length, but we want to make sure it has the opposite direction. Now, some operations with vectors, we can add two vectors and we can subtract two vectors. And to add two vectors, we can use one of these methods, parallelogram method or triangle method. Let's say U is this vector, another notation for vectors, and V is this vector. So if I want to add them using parallelogram method, I'm going to draw the U vector, and then I will move the V vector so that the tail starts at the tail of U. So we would draw a parallel, we would draw V so that it's parallel and the same length with this. Now, parallelogram method says construct a parallelogram, so that I'm drawing here a vector that it's parallel to V and it has the same direction and it has the same length, and the same with U. So we just noticed that we constructed a parallelogram, and this diagonal here, the longest diagonal, it's actually U plus V. So it's called parallelogram method because we are actually constructing a parallelogram, and the longest diagonal of the parallelogram is the sum. So the key is to make sure you put both vectors starting at the same point. If we want to add U and V using the triangle method, again, we start with U, the same length as the U we have. Let's not forget, these are the two vectors that we are dealing with. And then we draw V starting with the tail starting at the head of U. So this would be V. So the triangle method says your sum u plus v is the side of the triangle that starts at the beginning of u and ends at the end of v. And if we compare the blue one with the red one, I don't have a red, with this one, we see that they have the same direction, they have the same magnitude. Now, if I want to subtract, let's say I want to do u minus v. Well, I'm going to draw u, the vector u, parallel to u and the same length. And then I'm going to draw v, but I know that subtraction, it's actually adding with the opposite, right? So I am going at the end of u and draw negative v. So this would be negative v. So when we connect these two, we actually got u minus v, because we used triangle method for addition, but we added the opposite. So another way we can subtract is we draw u and we draw v, both starting at the same point. And if we draw this vector here, because it ends at the same point where u ends, we have u minus v. If I had the same u and v, the original ones, and I drew this one, we would have v minus u. So whenever the end point is, then that's the vector that we start subtracting from. So if we check this vector here with this vector that we got here, we see that they are parallel, they are equal to each other. And if we compare it with this one, we notice that they are parallel to each other, so they have the same direction, so they have the same length, but it's the direction is opposite, so that's exactly opposite of u minus v, it's v minus u. Let's talk about vector components. So vector can be written using u1, u2 with this arrow, with these arrows here, and another vector can be written v1, v2. These are representation of positive position vectors. So if u1 is here and u2 is here, then this vector here is vector u. So vectors are equal if they have the same length and direction. So in other words, u, which let's remember u was u1, u2, and v was v1, v2. U equals v is if u1 equals v1, so the x components are equal to each other, and u2 equals v2, so the y components are equal to each other. Now, since we are dealing with coordinate system and not all the vectors start at the origin, let's take a look at them from having points in the coordinate system. So if P is here and Q is here, right? So P is of coordinates x sub 1, y sub 1, and Q is of coordinates x sub 2, y sub 2. We can look at PQ as a vector, right? Which has magnitude. So PQ can be written as x sub 2 minus x sub 1 if I want to use a component format. So it's this distance, right? Because it doesn't start at the origin. And then is this distance, y2 minus y1. So the magnitude of PQ, right? We are using a right triangle. So using the Pythagorean theorem, we have x sub 2 minus x sub 1 squared plus y sub 2 minus y1 squared. But if the vector is written in the form v1, v2, then the magnitude of v is going to be, if the vector starts from the origin, and this is v sub 1, and this is v sub 2, in order to find the magnitude of v, we are just writing v sub 1 squared plus v sub 2 squared. So if we want to do operations with vectors that are written in using the x component and y component, right? So if I have u like this and v like this, u plus v, we are adding just the x components first, and then we are adding the y components. To subtract, same, x components first and then y components, and then if I want a constant times u is going to be cu1, cu2. So we are multiplying the constant to each of the. Let's talk about unit vectors. So a unit vector is any vector of length 1. So if this is my coordinate plane, x, o, y, and this vector here, this is 1 and this is 1, this vector, it's a unit vector. So the coordinate unit vectors are I, of course, that is 1, 0. So basically this vector here, it's the I vector. And this vector here, it's called the J vector. It's 0, 1. So in general, a vector v can be written v1 times 0, 1 plus v2 times 0, 1, which means v1i plus v2j. So how to construct unit vectors? If v is written as v1, v2, its length is square root of v1 squared plus v2 squared. So the unit vector, it's v divided by the magnitude of v. That is a unit vector. So for example, find the unit vector of a v 3, 4, right? So basically v, it's 1, 2, 3, and 1, 2, 3, 4. So this vector here, it's vector v. They want us to find the unit vector. So the magnitude of v is square root of 9 plus 16, that's square root of 25, that's 5. So the unit vector v over magnitude of v is going to be 3, 4 over 5, which means 3 over 5, 4 over 5. So that would be the unit vector. And you can check that, like for example, if I rewrite as u is 3 over 5, 4 over 5, the magnitude of u is actually square root of 9 over 25 plus 16 over 25, and that is 1. So where is that vector located? Well, it's 3 over 5, so that's 0.6, so it's around here. And 4 over 5, that's 0.8, so it's around here. So this vector here, just this piece, the red one, is the unit vector of v. So let's solve a couple of problems using vector. The water in a river moves south at 7 kilometers per hour. A motorboat travels east at a speed of 30 kilometers per hour relative to the water. Determine the speed of the boat relative to the shore. So let me draw the coordinate plane to make a picture. I think that every time we draw, and if you draw correctly, your chances of solving the problems are much higher, or you solve 90% of the problem. The water in the river moves south at 7 kilometers per hour. So south is this way, right? So don't forget east, west, north, south. So it goes south at 7 kilometers per hour. 7 kilometers per hour. And the motorboat travels east, so this way, at 30 kilometers per hour. Determine the speed of the boat relative to the shore. So let's find out the resultant vector here. So this is the resultant vector, and we want to find out its, because we want to find the speed, that means we want to find its magnitude. Let's call it vector u, and let's find the magnitude of u. So we are getting, we have a right triangle. This is 7 here, so we have square root of 30 squared plus 7 squared, which is square root of 949, and that is approximately 30.8 kilometers per hour. Let's solve another example. A commercial jet flies west to east at 500 miles per hour relative to air, and it flies at 600 miles per hour at a heading of 10 degrees north of east relative to the ground. Find the velocity of the plane relative to the air VA, the velocity of the plane relative to the ground VG, and crosswind W. Find the speed and heading of the wind. So let's make a picture of this. So let's say this is east, west, north, and south. So it flies west to east at 500 miles per hour. So let's make this our relative to air. So VA, the magnitude is 500 miles per hour. So this is VA. And it flies at 600 miles per hour at a heading of 10 degrees north of east. So this is east, and it goes 10 degrees up. So this is 10 degrees. This is relative to the ground, so VG. So the magnitude of VG is 600 miles per hour. And we want to find the velocity of the plane relative to the air. We did that. This is the velocity, this is the speed. So the velocity is the vector VA, which is 500. We can write it in this component form, 500 0, or we can write it 500 I. VG, so VG is, well, we have to do a little bit of math to do that. So we want to find out the x component. This would be VGX, right? And we want to find out the y component. So to do that, we are going to look at the triangle, at this triangle, and write sine of 10 degrees is the opposite side, which is y over the magnitude of VG, which is 600. So y equals 600 sine of 10 degrees. and that is approximately 104.2. And then let's do cosine of 10 degrees. That is x over 600. So x equals 600 cosine of 10 degrees, which is equal to, let's calculate that, times 600. That is 590.9. So VG can be written as 590.9 and 104.2, or we can write it 590.9 I plus 104.2 J. So these are VA, the velocity, and VG as vectors. So then we want to find the crosswind. We know that VG, the vector or the velocity relative to the ground, is VA plus W. So W is VG minus VA. So VG minus VA, which if we want to show that in the picture, it would be this vector, W. So if we subtract these two, we are going to get equals, so we subtract the i's, so it's 90.9 I plus 104.2 J. So, or we can write in component form 90.9 comma 104.2. So if I want to find the speed, then we are going to do square root of 90.9 squared plus 104.2 squared, and we get 138.3 miles per hour. That's the speed of the wind. Well, that's a very high speed. So in part B, we had to find the speed, which we did. So I'm going to consider this part B, and the heading of the wind. So if we look at the heading of the wind, right, so this one is the direction. So if I want to find out the direction, the heading of the wind, let me draw this W. How about we make W a vector like this? And I want to find this theta. So I know that the component, the x component, it's 90.9, and the y component is 104.2. So tangent of theta is the opposite side, which is 104.2, over the adjacent side, which is 90.9. So theta is arctangent of that ratio. So it's arctangent of 104.2 over 90.9, which means theta is 49.1 degrees. So in other words, the heading of the wind is 49.1 degrees north of east. And I redid this vector W. We can see that it's a little bit different, like why this one is slanted this way while this one is slanted differently. It's because, so this is W, it's the reason is my my velocity VG, it's actually, it should have been much longer, because if you can look at VG is 590.9 and this one is 500, so it should have been much longer. And then when we subtracted them, we could see how W would be slanted this way.